all, I would like to thank the SRM organizer for conducting this workshop. So as per the schedule, so we are having two topics. First one is introduction to SPSS. So first we will be seeing what are the interfaces are available in SPSS. So followed by we will be seeing how to enter the data and what are the data types. So before that, I want to start this workshop with a caution. So for learning any software, first step is you have to install the software. So I hope you have already installed the software. So the organizer already they have shared the installation procedure. So whatever software it is, so either it may be SPSS, Stata, or Studio, whatever it is. So first step is you have to install, you have to do the installation. So then only you can able to learn. So also I have to inform you that, so since it's a one-day workshop, you can't able to learn entire thing. So to learn or to be expert in the SPSS, so you have to do continuous practice. Then only you can able to be an expert in this SPSS. So also you have to learn all the softwares. So like SPSS. So generally we will have Excel. So Excel is the basic thing. So then next step is SPSS. So followed by other advanced statistical packages are there. So Stata is there, RStudio is there. So SAS is there. So first step is, so you have to explore the softwares. So then only you can able to choose which software is suitable for you. So according to your analysis, according to your objective, so you can able to select whichever software is preferable for you. So with this caution, so I am just starting my lecture. So as we know that today topic is exploring the SPSS, so how to do the statistical analysis. So SPSS in the sense, statistical packages for social science. So we know that it is also used for other sciences also. So generally they have mentioned that it is mainly for social sciences. Other than social sciences, even agriculture science also they are using for their analysis purposes. So just I'm going to show what all of the interfaces are available in the SPSS. So first step is, so you have to open the SPSS. So here SPSS. So once you open the SPSS, so better you can pin it in the taskbar. So for easy access, so you can able to pin it in the taskbar for easy access to the SPSS software. So there are different versions are there. So earlier version, so I think before 16, so it has different packages. So but in the new version, so it will be saved in the extension of .sav. So when you are opening, so you have to right click and pin it to the taskbar. So for easy access for opening, so you can pin it in the taskbar. Hope my PPT is visible for you. So generally, before introduction to the SPSS, so you have to know what all the basic things can be done in the SPSS. So first we will be seeing the interface, what are the existing interface in the SPSS. So followed by we will be seeing how to work with the SPSS files. So followed by we will be seeing how to define the variables in SPSS, because after collection of data, so you have to enter the data in the SPSS. Otherwise, you have to import the files or data files into the SPSS. Even though it is in different formats. So even it is in Excel format or SPSS or Stata format or RStudio format, whatever format is there. But to enter the data, so there are some procedures in SPSS. So next one is variable recoding. So recoding in the sense, so for example, while entering the data, I have coded it as male and female, but I want to convert it into 0 and 1. So how to recode the variables? So according to your objective, so you have to recode your variables. So next we will be seeing dummy variables. So dummy variables is an interesting topic in econometrics. So even for normal analysis also, even for t-test or whatever test,
So you have to use this dummy variable, like converting it into 0 and 1. So then binomial dummy variable is there. Other than that, multinomial dummy variables are there. So we will be seeing how to do this, how to convert this dummy variable. So then we will be seeing selecting cases. So selecting cases in the sense, so even though I am having n number of data, so like for example, I am having some 10 states data. So but I want to work only for particular state data. So in that case, I can able to select the cases. So similarly, I can able to split the files. I can able to give the weights for the data. So these are all the basics which we are going to cover. So I don't know, it's not a hands-on training. So, but I'll be showing how to do this dummy variable, how to convert or how to recode the variables, how to split the file, how to give weightages, and all other things we will be seeing in the further slides. So other than that basic, so we will be creating charts. So even each software has some different advantages. So in the case of SPSS, it's mainly on menu driven. So as I said that Stata is available, RStudio is available. So in the case of RStudio, mainly it is based on coding. So even though if you are not having coding languages, so if you are prefer SPSS, then you can do the menu driven analysis. So in the case of Stata, so it has both menu driven as well as coding. So some advanced statistical can be done in coding using the Stata. But in the case of SPSS, so 90% of the analysis will be done using the menu driven only. So it is very easy. You don't need any coding languages also. So after the basic, we will be seeing how to create the charts in SPSS. So there are different types of charts are there: column charts, line charts, scatter plot charts, box plot, diagram, and all other things. So we will be seeing how to create the charts in this class. So after that, we will be seeing some basics of simple analysis techniques. So like how to do frequency procedure. So for which type of data you have to use the frequency procedure, for which type of data you have to use the descriptive procedure. So on the other hand, you will be seeing how to do the explore procedure. So that is mainly for whether your data is distributed normally. So whether you are having some outliers. So for that, we will be using the explore procedure. So followed by, we will be seeing mean procedure and cross-tab procedure for doing chi-square statistics and all other things. So just I'm showing what are the available features of SPSS. So we will be working on a few features based on the availability of time. So after that, whatever analysis you are doing, so before that you have to check the assumptions. So major assumptions are normality. That means that your data should be distributed normally. So whatever data you are collecting in the field, or it may be a secondary data, so you have to check the normality of the distribution. So how to check the normality, we will be seeing. So whatever test, so it may be t-test or correlation or regression, whatever test it is. So you have to check whether it has satisfied all the assumptions. Example, mainly these two assumptions will be exist in all the analysis, like normality distribution test. Another one is outlier. So I think you know what is meant by outlier. So there are different types of outlier we will be seeing. So how to detect the outliers. So when these two assumptions are satisfied, then only you have to perform your test. So either it may be t-test or correlation or regression, whatever it is. So finally, we will be seeing the data transformation, how to transform the data. So when the data is not normally distributed, so then we have to convert the data. So that is called data transformation. So we will be seeing how to transform the data. So based on the skewness and kurtosis, whether it is positively skewed or negatively skewed, so accordingly, we will transform the data. So followed by, we will be seeing some one sample test. So within one sample test, we will be seeing what is meant by binomial test and chi-square test for goodness of it. So then followed by, we will be seeing the association of test. So generally we will have different, so if my objective is to see the association between the two variables. So then, so for example, generally we will have two objectives. So one is, so for example, my objective is to see the relation between the two variables. For example, yield and fertilizer. So if my objective is to see the relationship or association So according to my objective, I have to choose the test. So correlation. So for example, if my objective is not to see the relationship or association, so my objective is to see the impact between, so what is the impact of fertilizer on yield? So in that case, my objective will be different, like regression. So according to your objective, you have to select the test. So before conducting your test, so you have to check the assumption whether these data are having or satisfy the assumptions. So generally, most of the statistical analysis will have generally two assumptions. One is data should be distributed normally. So whether your data is normally distributed or not. So other one is outlier. So these are the major two assumptions. So other than that, there are different assumptions according to the test which you are going to use. So you have to check the data is normally distributed and if whether any outliers are present in the data. So according to that, so you have to choose the test. So we will be seeing those things in the further slides. So we will be seeing what is meant by Pearson correlation test. So when we have to use this Pearson correlation test. So I have said that to see the association or relationship. So we will be using correlation test. So within correlation test, there are two different types. One is Pearson correlation, another one is Spearman correlation. So according to your data, you have to choose the test, which test you want to do. So we will see those things in further slide. So it's an introduction. So first we will be seeing the basic thing. So after that, we will be seeing the charts, how to do the charts. So on the other hand, simple analysis like frequency, descriptive, so explore procedure, means and cross table procedure. So followed by, we will be seeing assumptions, so how to check the assumption, especially, so how to check the normality and how to check the outlier. And we will be seeing, so if the data is not normally distributed, so how to transform the data. So followed by, we will be seeing one sample test. So followed by, we will be seeing the association test like Pearson, Spearman correlation. So on the other hand, what is meant by partial correlation, how to do these things in SPSS. So then we will be seeing how to do the chi-square test when we have to do this chi-square test and all other things. So then we will be seeing test for mean difference. So initially we have seen one sample t-test. So before these things, you have to have some understanding what is meant by t-test, what is meant by independent sample t-test, when we have to use paired sample t-test. So what is meant by one-way ANOVA, two-way ANOVA. So I have given some example. So also I'll try to show it in SPSS also. So since it's due to paucity of time, so it is difficult for you to do the analysis, but I'll be sharing those. I think organizer will share the working files with you. So as of now, you just listen the presentation. So afterwards, you will be, you can able to have a Humpty number of time to do the analysis on your own. So then we will be seeing the test for mean difference. So what is meant by ANOVA? So these are all some of the non-parametric tests we will be seeing. So mainly predictive techniques are available in the SPSS. So like, so once you've done the regression, so you can able to do the predictive analysis. So since first two classes are based on the basic thing, so we are not going to in deeper in these things. So then we will be seeing the scaling technique. I think in the afternoon session, you will be having how to see the probability value. So how we are saying it is significant and how it is not significant. So all the other things we will be dealing in the afternoon session. So also you will be having the session, especially for PCA, that is principal component analysis. So that is a kind of scaling technique. Sorry, data direction technique. So PCA component, that is principal component analysis. So cluster analysis, so these are all the available options in the SPSS. So now we are going to start with the basic. So as I said that in the basic thing, so you will be having an introduction about the interfaces. What are the interfaces available in the SPSS? So how to enter the data, how to enter the variables, what are the different types of scaling are available in the SPSS. Okay. So as I said that first you have to open the SPSS since we have pinned it in the taskbar. So you can open. So once you open, so here you can able to see that. So here it has already some sample files. So if you are new to SPSS, so even you can use the sample files. That means that already they have stored some data in the SPSS. So whichever data you want, you can click and open. So automatically it will be opened. Then recent files. Okay. So that means that so if I am working these files in some particular folder means, so then you can able to immediately get these recent files. Otherwise, so if you want to start a new data set, so then you have to click here, new data set. Okay. So this is one of the way. Otherwise, sometimes I'm just closing this, how to do or how to open the SPSS files means. So here you have to go to file. Okay. So I'll just show it here. If I put it in side by side, it is easy for you to understand the procedure. So as I said that how to open the new file. So you have to go to file. So you have to click open. So here data will be there. So here you can able to open the new data. But if I want to open the already existing file means, so you have to go to file, then open, then data. Okay. So here you can able to search the file. Okay. So by browsing, so for example, my data is in desktop. Okay. So in that case, I just desktop, I have to select the desktop. So within that, I kept the files in the final. Okay. So here you can able to get the data. So by clicking this file, whichever file you want, so you can able to open. Okay. Otherwise, it is easy for you to open. Okay. By clicking this open data document, directly you can able to open. So otherwise, here you can able to see file. So even you can go to the repository, or else here you can see. So what are the recent used data? Okay. So since I didn't use the data in this desktop, so that it is not showing anything. So if you want to open the recent user data, so by going file, then you have to click the recent used file. Then you can able to open. So the procedure has given here. Okay. So hopefully it will be shared later. Okay. So how to create a new file? So first you have to go to file. Okay. So just I'm showing. So you have to go to file, then new. Okay. So then data. So for creating the new file. Okay. How to open the existing file? So for that, first you have to go to file. Okay. Then you have to click open. Okay. Then data. Same procedure. So as I said that how to open the recent file also. So now we are moving to the, so here you need to note that. So once you open the, so for example, I am just opening the new file. Okay. So file, new, okay, data. So it will be opened. So once you open the file, okay, there will be two windows. One is variable window, another one is data window. Okay. So data view or variable view. Okay. First, what you have to do. So first, if you want to enter your variable, so here you have to give the name, type, with decimal, label, and all other thing. So I have mentioned here what is meant by label and all other thing. So name is nothing but what is the variable name. Okay. So for example, we will take one example. Okay. So for entering the data. So for example, here this is the data we are going to enter. Okay. So our database, that means that we are going to create a new database in the SPSS. Okay. So our database consists of three variables. So one is marital status. Okay. Whether they are married or not. So second variable is age. Third variable is opinion about drinking alcohol. Okay. So I'm going to create three variables. Before that, you have to know the scales. Okay, so here you can see that in the SPSS file. Okay, so you have to first you have to give the name. So as I said that first we have to give the name of the first variable. Okay, so name of the first variable is marital status. Okay, so I'm just typing marital. So here it won't allow the space and all other thing. Okay, so even instead of space, so we will be using the underscore. Okay, so for typing the name of the variable, so I'm just typing three variable. First one is marital, second one is age. Okay, third variable is opinion about drinking alcohol. So I'm just typing alcohol. Okay, so then you have to type the select the variable. Okay, so what is the type of the variable? So I'm just mentioning it as numerical variable. Sometimes, so if you want to change it as a dollar or date, whatever it is. Okay, so by clicking here three dots, okay, you can able to see different types of options. Like if it is a dollar, so that means that if you are putting salary in dollar, or if you want to change the Indian rupee, then you have to click the custom currency and you have to do the changes. So as of now, I am keeping it as a numeric. Okay, I'm just selecting the numeric. So then for width in the sense, so that means that what is the length of this variable name? Okay, so I'm just mentioning it as 8. So similarly decimal. So decimal in the sense that means that, for example, I am putting age. Okay, so whether it should be a whole number or if you want to allow some decimals. Okay, so for example, if it is a qualitative variable, so generally we want to use the decimals. So but if it is a scale variable, so we will be using the decimals. So how many decimals you need after that point? Okay, for example, my age is 26, so 26 point 6 month or 7 month, whatever it is. Okay, so how much decimal you are allowing? So for that you have to keep this decimal. So then label. Okay, so here you have to give the label. Okay, for example, marital status. Okay, that means that I'm just typing marital status of the respondent. Status of the respondent. Okay, so I'm just giving the label for this variable. So next one is value. Okay, so that means that so marital status, so only we have two options. One is married or not married. So in that case, I have to name this or value this variable. Okay, by clicking these three dots. Okay, so you have to give the value. Okay, for example, I am valuing that. For example, so if it is one is not married. Okay, so for that I have to type one not married. Okay, so then you have to click add. So since two variables are there, so I am just clicking two is married. So once you're done, you have to click OK. So then if you want to, if you are having some missing value here, you have to give. Okay, so since there is no missing value, okay, so even you can give. So for example, so if there is a missing value, so you can able to command it to give 0 or whatever value you want. So but if you are giving some missing value as a 0, so for the analysis purpose, it won't take it as a 0. That means that so it will consider as a missing value, but it will provide some value. Okay, so since there is no missing value, I am clicking this option, no missing value. Then column. Okay, so then what is the alignment and all other thing. So this is the main thing, that is measure. Okay, so generally we will have 4 types of scales. Okay, so generally we will be having 4 types of scale. One is ratio scale. Another one is interval scale. Another one is nominal. Another one is ranking. Sorry, nominal is otherwise called as ranking. Okay, so So generally, first these two scales are considered as quantitative variable. For example, so if it is a ratio in the sense, for example, if it is a temperature, age, okay, so which are all continuous, okay. So generally, those are said to be the ratio scale or interval scale. So another one is nominal scale, okay. So nominal in the sense, another one is ordinal is there, okay. So nominal in the sense, so generally there is a difference. So these two are qualitative, okay. So this is continuous, okay, this is qualitative. So qualitative has classified into nominal and ordinal. So there is a small difference between nominal and ordinal. So nominal in the sense, okay, so for example, I'll give the example, okay, male and female or gender, okay. So with regard to ordinal, okay, so it may be a scaling. For example, what is good, okay? So good, bad, okay, neutral. So most of us are statistical or social science. We will be using some ranking, okay? So 1, 2, 3, 4, 5. So okay. So for example, whether it is good, bad, or neutral, okay, average, whatever it is, okay. So in that case, you can able to rank. So name of the meaning of ordinal is nothing but ranking. You can able to rank the variable. For example, small farmer, medium, large farmer are there. So in that case, you can able to rank them. Okay, small is okay, initial, okay, medium, final is large. That means that you can able to rank. But in the case of nominal variable, you can't able to rank. For example, gender. So who is big? Okay, so whether who is greater, whether male or greater or female or greater, you can't able to say. Okay, so in that case, it is said to be the nominal. Okay, so for that, so we will be seeing the measures. Okay. So you have to select the measure. So since it's a marital status, so in that case, you can't able to say which is greater or which is lesser, whether married is greater or unmarried is greater. So you can't able to say. In that case, it is said to be the, okay. So it is said to be the nominal. Okay. So if it is rankable, okay, so that is said to be the ordinal scale. So then a role is input. Similarly, now we are going to type it for the age. Okay. So age in terms of years. Okay. So here I am going to, so here decimal, I am just reducing the decimal. Okay. So then age. Okay. So age, I am just keeping the decimal. Okay. So here I have to click the label. Okay. So age of the respondent. In terms of years. So then you have to click the, so since the value is a continuous value, so you don't need to give any coding. So then there is no missing value. So then you have to select the major thing is measure. Okay. So it is a scale measure since it is coming under the ratio scale. Okay. So you have to select the scale. Okay. Then finally you have to select the third variable option about drinking alcohol. Okay. So here I am just reducing the decimal. Okay. So here I have to give the label. Opinion about opinion about the alcohol drinking. So here you have to give the value. Okay. So for that you have to click the three dots. Okay. So here in the slide I have given it's a 7-point scaling. Okay. So if it is 7-point means, so here you can see first point is totally disagree. Okay. So for that I have to click, okay, 1. Here label you have to click totally disagree. Then you have to add. Okay. So similarly you have to select values. Okay, for second. So I have given second value. So for that, what is the label? So disagree. then you have to add. Okay, so third one is somewhat disagree. Somewhat disagree. Fourth one is neutral. So fifth one is somewhat agree. Then sixth one is agree. Finally, seventh one, totally agree. Once you're done, you have to click OK. Okay, so now we have created 3 variables. So finally, we have to select the measure. Okay, so we can able to rank. Okay, we can able to rank the scales. So from 1 to 7. So in that case, it should be a ordinal. Okay, so if it is a ranking, then it is ordinal. Okay, even in economics, we will be having cardinal utility and ordinal utility. So ordinal in the sense rankable. Rankable means, so for example, preference can be ranked from 1 to 7. But in the case of marital status, you can't able to rank which one is greater and which one is lesser. So in that case, it is nominal. Okay, so once you're done, so we have to go to the data view. Okay, so far we have seen variable view. So in the variable view, so we have created 3 different types of variables. So in different measure, one is nominal, one is ordinal, final one is scale. Okay, so once you go to the variable view, data view, so you can able to see the variable name. Okay, marital, age, alcohol. Okay, so here you can able to copy and paste it from Excel. Otherwise, you can able to type. Okay, so for example, I am just typing. Otherwise, you can copy, paste it from the Excel also. So I am just randomly typing. Okay. So on the other hand, if you want to check the value, so if you click the marital, automatically it will be opened. Okay. So I have given coded 1 and 2. Okay. So here 1 to 7. So I'm just going here. Marital status generally 1 and 2 will you should have given. Okay, 1. I'm just randomly typing. Okay, so then age. Okay, so since I have given 2 decimal, so it will be allowed up to 2 decimal. Okay, so just I'm randomly giving. Okay, so final one is alcohol preference. Okay, so we have given ranking, so I'm just typing. Okay, so this is how you have to create the data, how to enter the data. Okay, so once you're done, you can able to save the data. Here one option is there. Okay, so here you can see, so A, that is value label. Okay, so if you click the value label, okay, so you can able to see your coding also. So initially you have given only coding. Okay, so 1 to 3, sorry, 1 2, similarly 1 to 7. Okay, so if you want to see the actual label, so if you click the value label, automatically it will be shown. Okay, so once you're done, so you can able to go to file and you can save the data. Okay, so wherever you want. Okay, so here you can see that. So generally the extension of SPSS will be in .sav. Okay, so other than that, you can able to save this data in different format also. So CSV file you can able to save. Okay, there are different form extensions also available. Okay, so you can save the data. Okay, the latest version is extension will be .sav. Okay, so then you have to click the save. Okay, so wherever you want, you can save the data. Okay, so you can change the file name also. Okay, so I'm just as of now. Okay, So even the file which has shared, okay. So I have shared the file with you. So first one is defining variable. So if you open the file, so you can able to see the datas. Okay. So if you click the variable value label, okay, so it will be shown value as well as coded. Hope so far it is clear. Okay. So next we are moving to variable recoding the variables. Okay. So for that, so just an introduction. So there are some 5 categories of farmers. Okay. So generally marginal farmer, small farmer, semi medium, medium and large farmer. Okay. So this is my data. Okay. So now I want to code the data. Okay. So I have coded the variables into 2 different category. Okay. So actually I have coded from 1 to 5, but I have to recode the variable. That means that so vulnerable farmer and non-vulnerable farmer. So if I am giving 1 means so they are vulnerable, and 2 means they are not vulnerable. Okay, so in that case, I am considering that small and marginal farmers are vulnerable. So remaining farmers are not vulnerable farmer category. So in that case, how to do the recoding in the SPSS? So for that, I am just opening the data. Okay. So recoding the variable, already it has shared, I think. Okay, so later you can exercise those data. Okay, so once you open the data, okay, so this is the data. Okay, as I said that there are different categories of farmer. Okay, different 5 categories of farmer. Okay. Okay. Inform பண்ணுவாங்க அவங்க இன்ஃபார்ம் பண்றாங்களா இல்ல அவங்கள வந்து சொல்ல sir, this is the farmers data. Okay, so as I said that there are different types of format as well as their salary. Okay, on the other hand, their satisfaction level we have given. Okay, so now our intention is to recode the data, okay, into 2 different category. One is vulnerable group, another one is non-vulnerable group. So in that case, what I am going to do is so recoding the variable. Okay, so for that you have to click the transform. So for that you have to give the click the transform the variable. Okay, so here there is an option called transform. Okay, so within that, so there are 2 options are available. One is recode into same variable. That means that if you do that, it will collapse the original variable. So second one is recode into different variable. So that is an important instruction. Okay.
Hello. Dear participant, due to the recording will be paused now, so I request all to rejoin this program so that the recording will continue. Thank you.
2021 आहे रे बाबा इथे.
share Windows screen. Correct. Sir. Hope I am audible. So now we are going to do the recoding. Okay. So as I said that farmer types are available. So first we are going to recode the variables into two different categories. One is vulnerable farmer, another one is non-vulnerable farmer. Vulnerable farmer, we are considering the small and marginal farmers are considered as a vulnerable farmer. So for checking the coding, so you have to click the farmer type. So here you can able to see the coded values. Okay, 1, 2, 3, 4, 5. So first two are vulnerable farmer we are considering. So remaining are considered as a non-vulnerable category. So for that, what we have to do? So first we have to click the transform. Okay, then recode into different variables. Okay, so then we have to select the variables. Okay, so as I said, the type of the farmer. Okay, so I am just selecting the type of the farmer. Okay, so then you have to click the name of the farmer. Okay, so for example, I am just providing okay type underscore new, whatever it is. Okay, so if you want to give the label also, you can give the label. Then you have to click the change. Then you have to define the old and new values. Okay, so as I said that my old value is okay 1 and 2 should be considered as a vulnerable category. Okay, so I'm just clicking 1. Okay, so I'm just clicking 1. Okay, so that should be converted into recorded into 1. Okay, then I have to click add. Then I am clicking the second old value that should also be converted into category 1, that is vulnerable category. Okay, so here there are different options are there, all other variables, range and all other things are there. Okay, so then I am clicking, so 3, 4 and 5 should be converted into second category. Okay, so that is nothing but that is not vulnerable category. Okay, so once I done, okay, you have to click the continue.
Hello sir,
yes,
not able to see the slide sir.
You can't able to see the slide?
Yeah,
Wait
yes
a
sir.
minute, ma'am.
Please share again sir.
Wait a minute, ma'am. Wait a minute. Okay. Ma'am, I think it is showing.
Pardon me, sir, but we don't have the data files which you are working on. So,
Sir, you just share the data file with them. So they are asking us to share the data file. I think it has already shared in the WhatsApp group as well as email also. Otherwise, you just contact the organizer. Okay, they will share it to your email ID. Okay. PPT will also be shared later. Okay, so it is easy for you to do the analysis. Okay, so in the later time, due to paucity of time, we can't able to do the hands-on training here. Okay, so then what you have to do, you have to click the old and new. Okay, so then you have to click OK. Okay, so then you can able to go to the data view. So here you can able to see that type underscore new, that is new variable. So we have converted 5 scaling into 2 categories. One is vulnerable, another one is non-vulnerable. So even you can able to change the decimal also by clicking here. Okay, so here the decimal is 2. So I want to make it a 0. Okay, so once you're done, you can go to the data view and you can able to see the data. Okay, so even you can able to change this for continuous variables also. Okay, so quickly I'm showing. Okay, so for example, I want to convert the salary. Okay, so here actually you can able to record the salary into 2 different categories, that is low and high income. Okay, so in that case, for that you have to go to transform. Okay, so record into different variables. So here you have to click the reset. Then farmer salary you have to select. So output variable, I'm just selecting new salary. Then you have to click the change. Okay, then you have to define the old and new value. Okay, so here there is another option is called okay range. Okay, that means that, so I'm just mentioning that, so less than 5,000 sorry 50,000. Okay, so should be converted into value 1. Okay, that is low. Okay, so all other should be converted into 2, that is high. then click continue and OK. So then the entire salary can also be transformed into two different category. One is low, another one is high. Okay. So even you can able to do the reverse coding also. So for example, in the case of 1, 2, 3, 4, 5, that is totally agree to totally disagree to totally agree. So even you can able to change it into 5, 4, 3, 2, 1. So using the same procedure like transform. So here you have to again you have to do the same. That means that what is the old value and what is the new value. Accordingly, you can able to change the values. Okay. Next, we are going to see the dummy variable. So dummy variables generally it is said to be the categorical variable. So generally it will take two values. Okay, either 0 or 1. Okay, so it may be male or female, whatever it is. Okay, so we will be coding it as 0 and 1. That is said to be the dummy variable. So if your objective is related to dummy variable, so you have to change your data into dummy variable. Okay, so for that we are going to see a data. Okay, so that is binary variable. So binomial variable. So binomial variable consists of only two categories. Okay, 0 and 1. So even there are other categories also there. Okay, so here you can able to see that it is multinomial variable. Okay, so it is not binomial, it is multinomial. That means that more than two category. Okay, so first we will see the how to convert the binomial variable into dummy variable. So for that we will be using the employer's data. Okay, so I am just closing the data. Okay, and opening the employees data. Okay, so here they have given the employees details. Okay, so in the case there are different information like their gender, their job category, and all other things are there. Okay, so as I said that it is a binomial data. Binomial means only two categories will be there. Okay, so here the gender will be considered as a binomial. So in that case I am just transforming or recoding this variable into binomial one, that is 0 and 1. How to do that? So again you have to go to the transform. Okay, recode into different variable. Okay, so here you have to select the gender. Okay, so I'm just typing gender new or gender 2. Okay, then you have to click the change. Then you have to click the old value. Okay, before that you have to know that what is your gender. Okay, code. Okay, so I'm just clicking the gender and you have to click the value. Okay, so I'm just converting it as actually it is considered into female and male. Okay, so for that it is not so I have to convert it into 0 and 1. Okay, so F and M is that, so I have to convert it into 0 and 1. Okay, for that I am going to transform, then recode into different variable. So I'm just selecting the gender variable. So I'm just typing the new variable name gender 2. Okay, so then change. So F and M. Okay, so if I want to convert F, that is female, into 0, I have to code. Okay, so another one is male. So for that I have to convert it into 1. Okay, so once you're done you have to click continue. Okay, okay, so then you can able to see that. So here actually gender, okay, M and F will be there. So now the new variable, that is gender 2. So here you can able to see that. So it will be converted into 0 and 1. Okay, so actually the decimal is 1. So even you can able to change the decimal also, whichever you want. Okay, so here you have to go to decimal. Okay, and reduce the decimal. So once you're done, you can able to see the thing. Okay, so now we are going to convert the multinomial variable into dummy variable. Okay, so if you are aware about the dummy regression, okay, so when there is a multinomial variable is that, when you have to convert it into dummy variable, okay, generally 3 categories are there, then you have to convert it into n-1 category. Okay, so how to do that dummy variable in the multinomial variable? So for that I am just going to open the same employee data. Okay, within that I'm going to convert the job category. So first you have to check the job category. Okay, different categories of employees. So for that I am just clicking the value. Okay, so one is clerical, second is custodial, third is manager category. There are 3 different categories are there. So earlier case only 2. That's why we are saying that it is a binomial. But here you can able to see that there are 3 categories are available. So clerical, custodial, and manager. So for that, how to convert it as a dummy variable for running a dummy regression and all other things. Okay. So if there is 3 category, then you have to convert it into n-1. That means that so n is nothing but 3 minus 1. So 2 categories you have to select. Okay. So in the slide, it is clearly mentioned that. So here you can see that 3 categories are there. One is clerical, custodial, and manager. So you have to keep one as a reference category. So I am keeping manager as a reference category. So due to that, I have to create 2 dummy variable. So 2 dummy variable in the sense wherever clerical farmers are, clerical employees are available. So then I have to put 1. So remaining are 0. Similarly, in the case of custodial labors, okay, in that case, only for custodial employees only I have to put 1. Remaining should be 0. So how to do the recoding in the multinomial variable? So for that, again, you have to use the same procedure. Okay. So I'm going to the data view. So here you have to click the data. Sorry, not data. You have to click the transform. So in the transform, you have to do the recoding different variables. Okay. So I am going to create 2 different variables. Okay. So due to the dummy variable. Okay. So I'm just clicking the reset. So as I said that employment category. Okay. So employee category. Okay. This is the job cat. So I am just typing if it is a clerical. Okay. So in that single column, so there are 3 different categories are there. So I am just selecting. Okay. So if it is clerical, okay, so it should be 1. So remaining should be 0. Okay. So I have to click change. So click old and new value. Okay. So clerical actually it is 1. Okay. So in the new value also 1. But the remaining category, that is custodial and manager, should be 0. So for that, I am just clicking the all other values. Okay. Sorry. Before that, you have to click the value. Okay. Actual value is 1. So here you have to click add. Then all other values, that is custodial and manager, okay, should be 0. Okay. Once I done, click OK. So the new variable will be generated. Okay. So here you can able to see that if clerical. So wherever 1 you will be seeing, so that you can able to see the clerical. Okay. Other than clerical, custodial and manager will be 0. Okay. So then I have to convert the other dummy. Okay. That is custodial. So for that, again, I have to go to transform. So recode into different variables. Okay. Same job category. So here you have to select. Here I am just resetting. Okay. Transform. So here I have to reset. Okay. Same job category. Educational employee category, job cat. So if it is custodial, okay, so then you have to click change. Okay, you have to define the old and new. Okay, so here custodial will be the 2. Okay, I am converting it as 1. Okay, then add. So remaining should be, so it may be clerical or manager, that should be 0. Okay, so then continue. Okay, so new 2 dummies will be created. Okay, one is if custodial. Okay, if custodial and if clerical. So that means that if custodial, if clerical means only clerical employees will be coded as 1. So remaining 2 categories will be coded as 0. That is dummy. Okay. So similarly, if it is a custodial employee means, then that should be coded as 1. Remaining will be coded as 0. Okay. If you are dealing with the multinomial variable means, so you have to do the create the dummy like this. Okay. So now we are going to see the selecting cases. Okay. So selecting cases in the sense, as I said that if you are having large data. Okay. So the data were collected from different states. Okay. So some 10 states or 12 states. But my intention is to deal with only 1 state. So in that case, you can able to select the cases. Okay. On the other hand, so if you want to remove some particular column also, you can able to do. For example, so if you found that So some row number 7 or 10 or 5, whatever it is. Okay, if you found that it is a extreme values, so it's an outlier. Okay, so I don't want to remove. Okay, as of now I don't want to remove. Okay, but you can able to keep the same variable in the original data. But while doing the analysis, if you do this selecting case analysis, okay, it won't reflect in your analysis. Okay, that means that that specific rows will be skipped. Okay, so on the other hand, particular state or particular district you are working on, that means so remaining states or remaining district will be skipped. Okay, so you don't need to remove the data. Okay, so instead of that, if you use this selecting cases, you can able to do the analysis. Okay, so for example, I'm just selecting the same employee database. Okay, so I'm using the same employee database. For that, you know that in the job category. Okay, so here you can able to see this is the job category. So there are 3 different types of employees are there. Okay, so one is clerical, custodial, and manager. My intention is to want to work with only the manager category. Okay, so generally what we will do, we will remove the data of clerical and custodial. Okay, then we will create one separate folder for manager and we will start the analysis. But in the case of SPSS, you don't need to do that. Okay, so for example, as of now, without removing any category, okay, I'm just running the analysis. Okay, so for that, just frequency analysis I'm doing. Okay, so for that, I'm just going to analyze. Okay, so descriptive in frequencies. Okay, so the employee categories are there. I'm just selecting the employee categories. Okay, so I'm just clicking the OK. Okay, so this is the actual outcome. Okay, so there are 3 different categories of that: clerical, custodial, and manager. Okay, but now what I'm going to do, I want to work with only the manager category. Okay, so for that I'm going to use the selecting cases. Okay, so for that what I have to do, so you have to go to the so you have to go to the data. Okay, so here you can able to see the select case. You have to select the case. So within that you have to select the if condition is satisfied. So in that if condition, okay, so as I said that I want to work with only the manager category. I know that manager category is coded as 3. Okay, so I'm just selecting the so this is employment category. Okay, so I'm just selecting. Okay, so I just want to have only the 3rd category. Okay, that is manager category. Okay, so then I have to click the continue. Okay, then I have to click OK. So if you go to the view, so here you can able to see that it, you will have a cross mark. Okay, so other than that manager category. Okay, so here I am just making it as value label. So here you can clearly see that. So only for manager category. Okay, so other categories will be hidden. Okay, so now I am running the same analysis. Okay, so I'm just go to analysis. Okay, descriptive statistics. So here frequency. So same thing. Okay, I'm running the analysis. Okay, so here you can see that. So even though the data consists of 3 different categories. Okay, so earlier you can able to see the results: clerical, custodial, and manager. But after the selecting cases, so whatever data you have selected, the results will come only for that categories, that is manager category, since I have selected. Okay, so I got only the results for manager category. Similarly, you can able to select different variables for your analysis. Similarly, as I said that even you can able to so I need the original data. For that, what I have to do, again you have to go to the data, select cases. Okay, so here all cases you have to select. Okay, so if you click that, this hidden values will go. Okay, so I'm just clicking OK. Okay, so here you can see that. So now all the variables are selected. Okay, similarly, as I said that even if you found that some of the column, okay, so some of the column are having some extreme values or some outliers. Okay, so if you want to remove that particular column only. Okay, so in that case, so same procedure you have to follow. So you have to go to data, then you have to click the select cases. Okay,
here you have to click the if condition. Okay, so here you have to click the reset. Okay, so if condition, so here you have to type, so generally the dollar symbol. So for example, I am assuming that my 5th row and 7th row are having some extreme values or outliers. Okay, in that case I am just typing case num, okay, case number, then less than and greater than symbol. Okay, so as I said that 5, okay, will be the outlier, and similarly dollar symbol, case num, less than and greater symbol 7. Okay, so then you have to click continue and OK. Okay, so here you can see that, so only that outlier file. Okay, so I assume that 5th and 7th row are having the outliers. Okay, so if you do the analysis now, so this outliers will be eliminated, okay, from your analysis. So as I said that, to go back the original data, so again you have to go to select cases. So you have to select all cases and OK. Okay, so then you will get the original data. Okay, so another one is file splitting. Okay, so it is also useful to run the same analysis on several groups. Okay, for example, I am running, so for example, if I want to calculate the salary, okay, so whatever analysis I am doing, so it should be classified into 2 different categories or whatever categories you want. For example, I want to do the analysis, okay, whatever analysis I am doing, it should be differentiated between the gender. Okay, that means that the file will be splitting between male and female. Okay, so whatever analysis I am doing, so it will be splitted into 2 categories. Okay, for example, assuming that, so I'm initially I'm just do some descriptive statistics for salary. Okay, what is the average salary? For that I am just picking the analysis. Okay, so go to descriptive statistics. That means that it is before doing the file splitting. Okay, so descriptive. Okay, since it's a continuous variable, I'm just using the descriptive statistics. Okay, so I'm just selecting the current salary and I am clicking the OK. So once you're done, so here you can see that what is the minimum, maximum, number of observations, standard deviation, all of the things will come. But I want to split this file into 2 different categories. That means that whatever analysis I am doing, it should be classified into male and female. Okay, so for that, what I am doing, I am just using the file splitting option. Okay, for that, what I have to do, so you have to use the same file. Okay, so within that, you have to click the data. So then there is an option called split file. Okay, so you have to click the split file. So you have to select the group. Okay, you have to click this organize output by group. Okay, so which category you want? Okay, that means that I want to make this analysis into 2 different groups. Okay, whatever analysis I am doing, it should be classified into 2 different groups for separately male and female. For that I am selecting the gender. Okay, so once you're done, okay, so once again I am going to run the same analysis. Okay, we'll see the results. So I am just go to the analysis, descriptive statistics. Okay, so then descriptives. So same thing is that current salary. Okay, so here you can able to see earlier only 1 category will be there. Okay, current salary, what is the number of observation? 474. Then what is the minimum, maximum, mean? Okay, but after splitting the file into gender, okay, so you will be getting different results for separately male as well as female. Similarly, whatever analysis you will be doing, so you will get different results for separately male as well as female. Okay, that is the advantage of file splitting. So even you can able to split more than 2 categories. Okay, so for example, again I want to do the file splitting. Okay, so data. Okay, file splitting. Okay, so here I have selected only gender. So even I can able to split the file into job category wise also. Okay, so for example here employment category. Okay, so once you're done, so once again I am doing the same analysis. Okay, the results will be splitted according to the gender as well as job category. So I am going to click the descriptive statistics. Okay, descriptive statistics. Okay, and okay. So here you can see gender, male, employment category, manager, employment category, custodial, clerical. Similarly, female also you will be getting results for separately manager, clerical, and other category. Okay, this is the advantage of file splitting. So next we are moving to the weighing cases. That means that so how to give the weights for the data. So for that I am just closing this sheet. Okay, so here weighing cases is nothing but I'm having a database. Okay, here weighing cases. So here the question is, how satisfied are you with our products? Okay, so here the question is, now I am in data view. So even if you want to do, you can check it in the variable view by selecting this satisfaction. So satisfaction class has classified into different category. Okay, 4 scale. One is very unsatisfied, somewhat unsatisfied, somewhat satisfied, and very satisfied. Okay, so here you can able to see the data view. So the data consists of only frequencies. Okay, so very satisfied, 2 members have mentioned, very unsatisfied. So somewhat unsatisfied, 8% has mentioned, somewhat satisfied, 19%. Okay, so very satisfied, 35%. So I want to give some weights. Okay, for example, if I am doing anything, okay, so before giving weight, I'm going to run the analysis. You can able to see the results. Okay, so in that case, what you are going to do, so you have to click the analysis. Okay, it is before giving the weights, how your results will be. So I'm just clicking the descriptive. Okay, frequencies. Okay, so I'm just clicking the how much you are satisfied. Okay, and you are clicking the OK. So you have to go to analysis. So descriptive statistics. Okay. So if you are not giving the weight, so you will not get the exact results. Okay, so in that case, you have to give the weights. So how to give the assigning weights? Okay, so for that, before that, you have to see that here you can able to see that only Unicode will be on. Okay, so here since the weight is already on, okay, so due to that I am getting this results. Okay, so first I have to turn off the weight. Okay, how to turn off the weight is nothing but you have to go to the data. Okay, weighing cases. Okay, so you have to do not wait and you have to click OK. Okay, so now you can able to see only Unicode. Okay, only Unicode will be on. There is no weight. Okay, so in that case, I am going to run the analysis, descriptive statistics. Okay, so then I am going to the frequency. Okay, then I am clicking the OK. So here you can able to see that frequency 1. Okay, somewhat unsatisfied 1, somewhat satisfied 1, totally 4. Okay, but I don't want this because my data is based on frequency. So that means that it is not individual observation. Okay, it is a pooled observation. So in that case, what I have to do, I have to give the weight. Okay, so you have to note that. So initially there is no weight on. So for that, you have to turn on the weight. How to turn on the weight? So you have to go to the data. Okay, so weight cases. Okay, so you have to click the weight by case. Which case? Based on the frequency. Okay, so then you have to click OK. Okay, so now we will see this is the earlier result. Okay, so now we are going to do the same analysis and we are going to check what would be our result after turning on the weight. Okay, so you have to go to analysis, descriptive statistics, frequency. Okay, so same, I didn't change anything. Okay, I'm clicking. So you will be getting the exact result. You can able to compare the earlier result as well as new result. So earlier result 11114. But after giving the weightage, you can able to see that frequency 2, 8, 19 and 35. So even you will be getting percentage, valid percentage and cumulative percentage and all. So this is the advantage of giving weightage. Okay. So now we are moving to the charts. Okay, so charts are more important. So there are different types of charts are available. Okay, so there are column charts, bar charts, scatter plot. So we will be seeing how to do the charts. Okay, so there are some condition, okay, to apply column charts. Okay, so column charts, so it is used whenever independent variable has discrete value. So discrete in the sense, so data generally it will be classified into two categories. One is discrete, another one is continuous. Discrete in the sense either it may be nominal or ordinal. So you know the difference between the nominal and ordinal. Ordinal is nothing but rankable, like 1 to 7. So you can able to rank. But in the case of nominal, in the sense it's a discrete value. That means that male and female you can't able to rank the values. That is said to be the nominal value. So when your independent variable is a discrete, okay, nominal or ordinal, you can able to use the column charts. So for that, I will be using the employee data. So I'm just closing this data and opening the employee data. So here you can able to see the employee data. Okay, so as you know that there are three different types of job category. One is clerical, custodial, and manager. So we are going to see the what is the average salary of each categories of employee. Okay, so here you can able to see that it is salary, it is in dollar. So even you can able to remove the dollar also. As I said that, so here you can able to see that values will be there. Okay, so even in the case of type, okay, so if you want to change it as a numerical, it will be changed. Okay, so if it is a dollar, you can able to change it to dollar. Okay, whatever date, okay, whatever you want, you can change. Okay, so I'm just changing it as a numeric. Okay, so then the dollar symbol will go. Okay, once I close the table, okay, automatically it will go. Okay, so my intention is to do the column chart. Okay, so for what is the average salary of the three different job category. For that, what I have to do, so directly you have to go to the graphs. Okay, so here you have to click the chart builder. So first time if you are opening, so it will be asking like this. Okay, so you have to click don't show this dialog again. Okay, and okay. Okay, so you will be getting the different types of charts. Okay, so defaultly it will be selected bar chart. So if your intention is to put a column chart or bar chart, okay, so if you want to put line chart, area chart, scatter plot, whatever you want, you can select. So column chart or bar chart more or less same. So I am just selecting the bar chart. Okay, to select, so within that there are different categories of charts are available. So my intention is to select simple bar chart. Okay, so I have to drag this here. Okay, once you're done, so as I know that as I said that generally this x-axis is nothing but this is the independent variable. So independent variable should be a categorical. So either it may be nominal or ordinal variable. So as I said that I have to check the categories. Okay, sorry, different categories of employee. Okay, what is the average salary? So for that I am just dragging this employee category, okay, into the x-axis. Then what you have to do, salary, okay, current salary into y-axis. Okay, so once you're done, here statistics will be there. Okay, so what is my intention? Okay, so if my intention is to see the what is the mean salary or average salary, I have to check. Okay, or maximum salary, minimum salary, whatever you want. So but my intention is to check the average salary of three different categories of the employees. Okay, once it is done, so then I have to click the okay. Then the data will be generated. Okay, so then, so if I want to put the label, okay, for that what I have to do, I have to double click the value. Okay, then you have to click the elements. Okay, so data labels. Okay, so here you can able to see that clerical average salary is comparatively low than the manager's salary. Okay, so then you have to close. Okay, you will be getting this one. So this is how you have to do the column chart. Then Now we are going to see, okay, so there are different charts within the column charts also, okay. So for example, I want to put two different categories. That means that gender wise, okay, as well as category wise average salary, okay, I can able to do. So for that, what I have to do, again, I have to go to graph, chart builder, okay. So you can reset, okay. So here you can able to see that second cluster bar chart, okay. So I'm just dragging this, okay. So again, I want to select the gender or job category, whatever you want, you can select, okay. For example, I'm selecting the job category, okay, in the x-axis, since x-axis should be a categorical variable. So then I want to select the salary. I'm just selecting the salary, okay. On the other hand, I want to select it gender wise, okay. So here you have to select. Then you have to check the statistics also. Then you have to click OK. Here you can able to see that. Here you can able to see that this is the average salary. So even you can able to do the label also, okay. So comparing to the female, you can able to see that male average salary are higher, okay. So on the other hand, comparing to clerical, so manager salaries are higher, okay. Now this is what about column chart. Now we are moving to the line chart, okay. Similarly, you have to go to the graphs, chart builder, okay. So you have to click the reset. Then we are going to do the line chart. So generally line chart will be used for time series analysis, okay. So but it can be represent for others bar charts. Instead of bar chart, we can able to use the line chart also, okay. So to differentiate the different categories, okay. So for that I am just, okay, so I will be using the different data set, okay. So I'm just closing this data, okay. So I am just opening the insurance data. So this is for line chart. So for different categories, how it will be. So here we are having the customer claims informations, okay. So like whether they have claimed, okay, so or not, what is their gender and all other things we will be having. On the other hand, education, what is their education, income, etc. Okay, so we are going to build the line chart, okay. For that, what you have to do, so you have to go to the graphs, okay. You have to click the chart builder, okay. So once you're done, you have to select the chart, which type of chart you want, okay. So for example, here you can able to see that here the line chart is that, okay. So here it is the line chart, okay. So here the education, okay. So I'm just considering the educational category, okay. So here you can able to see level of education, okay. So there are different levels of education, okay. So what is their salary or income, okay, household income, okay. So I'm just selecting the household income, okay. So when I click OK, you will be getting the line chart, okay. So on the other hand, you can able to put the trend line also, okay. So you have to do the double click. So then you have to go to the element, okay. So within that you have to select the so you have to click the interpolation line, okay. So whether it is straight, whatever it is, you can apply. Similarly, you can able to do more number of variables also, okay. Like for example, education category wise income, okay. Also, you can able to include the marital status, okay, for seeing the household income for different categories. So now we are moving to the scatter plot. Okay, so for scatter plot, generally it will represent the relationship between the two continuous variables. Okay, so earlier case we have seen one continuous and another one is categorical. Okay, but in the case of scatter plot, so if you want to see the relationship, so you have to use the scatter plot charts. Okay, so for that I am going to open the employment database. So I'm just opening the employment database. Okay, so here I want to see the relationship between the salary of employee at the beginning level as well as the current salary. Okay, so here you can able to see the data. Okay, so here you can see that salary, it is the current salary, begin is the beginning salary. Okay, so these two are continuous. So I am going to do the scatter plot. Okay, so since two are continuous variable, so for that what I am going to do, so you have to click graph. Okay, so go to chart builder, you have to select the scatter plot. Okay, so then you have to drag this scatter plot. So within that you have to select the beginning as well as current salary. Okay, this is the beginning, then I'm just dragging the current salary. Okay, here you can able to see the results of scatter plot. Okay, so it is linearly distributed. So even for distribution, for finding the outliers also, we will be using the plots, but different types of plots we will be seeing. Okay, so if you want to see whether it is linearly distributed or non-linearly distributed, if it is linearly distributed, then only you can able to use the linear analysis. Otherwise, you have to use the different analysis. Okay, for that you have to check whether it is linearly distributed. Okay, for that I am just selecting the graph, double clicking. Okay, then you have to go to the elements. So here fit line at total. Here you can able to see that. So it is the linear line. Okay, so if you are clicking linear line, it will show. Okay, similarly quadratic line means so which whether the data is distributed quadratically or not. So since it is linear, okay, so I'm just clicking apply. Okay, and close.
Sir, excuse me.
Yes.
Sir, can you repeat the scatter plot once again? I'm getting an error.
Okay. So once again I'm doing. Okay. So first thing you have to go click the graph, then chart builder. Okay. Then you have to select the scatter plot. Okay. I'm just dragging here. Okay. Then what I have to do? So I want to relate two continuous variables. One is beginning. Okay. Another one is current salary. Okay. I'm just dragging. Okay. So then you have to click OK. Okay, so you will get the scatter plot. So if you want to put, you have to check whether it is linearly distributed or not. So you have to do double click. Okay, so you have to go to the element and you have to fit line at total. Okay, so as I said that, so it is linearly distributed. That means that, so here this x-axis increases, y-axis will also increases. Okay, so when they are beginning, so initial salary is somewhat high. Okay, after that the current salary will also be higher. Okay, when their beginning salary is high, automatically their current salary will also be higher. Okay, so then you can able to do the linear analysis. Okay, because this data is distributed linearly. Okay, so that you can able to use the linear data analysis. Okay, then even you can able to do more things. Okay, for example, so graph chart, then I'm just resetting. Okay, so scatter plot, so I'm just dragging here. So then this is the beginning salary. Okay, and this is the current salary, but I want to see it in gender wise. Okay, so here you have to click the gender and set color. Okay, then you have to click OK. Okay, so here you can able to see that female are in blue color and male are in green color. Okay, so even you can able to set the trend line. Okay, so you have to double click. So you have to go to element, fit line at subgroup. So for each two different group, it will be applied. Okay, then okay, close. So here you will be getting two different trend line. Okay, separately for male and female. Then box plot, it is more important with regard to outliers, finding the outliers. Okay. So that means that, as I said, that for doing any analysis, you have to check the assumption. So most of the analysis will have generally two assumptions. One is the data is distributed normally. Another one is whether the data has any outliers. Okay, the data should not have any outlier. Then only some analysis will be applied. Then what I have to do? Okay, so I have to do the box diagram. Okay. So here you can able to see that it is very useful, okay, for studying the distribution of continuous variable. Okay, so mainly box plot will be used for. Hello. Okay. So first we will be seeing the box plot. So after this box plot, so we will break for tea. Okay. So after that, we will start by 11:45. Okay. So quickly I will complete the box plot. Okay. So generally box plot will be used for studying the distribution of continuous variables. Okay. So especially for detecting the outliers, as I said that. So before doing any analysis, we have to do this box plot to find whether the data has any outliers or not. Okay. So then only you can able to use the data. Okay. Otherwise you have to, there are some alternative measures are there, okay, for removing the outliers, whether we have to keep the outliers or we have to remove the outliers. Okay. So then only you can able to do the analysis. Okay. So quickly we will be seeing the how to do the box plot using the employee database. Okay. So here the employee database is there. So here you have to click the graph, chart builder. You have to click the reset. So then you have to click the histogram. Okay. So I am just selecting the histogram here. Okay. I want to see whether three categories. Okay. So as I said that the employee has three categories, whether the three category salaries are has some outliers or not. Okay. So for that, so x-axis generally it will be a categorical. Okay. So as I said that the employment category. Okay. I'm just dragging the x-axis. Okay. Generally the y-axis will be a continuous. Okay. So salary, I'm just taking the current salary. Okay. Then I am clicking the okay. So first you have to click the graph, chart builder. So you have to reset. Okay. So once you reset, you have to select the histogram. So you have to fill the element. Okay. So then you have to give the dependent variable and independent variable. Okay. So the dependent variable will be the, as I said that job category. Okay. So then salary. I'm just selecting the current salary. Okay. So if you want, you can able to see the statistics also. Okay. Sorry. So since actually it is a box plot, so we are selecting the histogram. Okay, due to that it is not coming. Okay, so here you can see this is a box plot. Okay, so you have to click the reset. Okay, and you have to select the box plot. Okay, so within that you have to select the employment categories. Okay, so then current salary. Okay, so to detect the outlier, generally box plot will be very useful. Okay, so you have to click OK. So here you will be having a box plot for three different categories: clerical, custodial, and manager. Okay, so here this is the box, and this dark line is said to be the median. Okay, this upper part of the box is nothing but quantile 1. Okay, so this this lower part is Q1 and this upper part is Q3. Okay, Q3 minus Q1 will be the median. Okay, so you can able to see the lower whisker and the upper whisker. So the values which are lies above the upper whisker are said to be lower. That means that if you are having some values above the whiskers, then you can able to say that the outliers are present in your data. Okay, so these are all the outliers. Okay, that means that so when it is distributed within this range between lower whisker as well as upper whisker, okay, then there is no issues. But if some data are distributed beyond the whisker, okay, then you have to tackle with that outliers. Okay, then only you can able to apply the t-test or whatever test you are using. Okay, otherwise the assumption will be violated. Okay, so with this we'll break for tea. Okay, we'll join by 11:45.
I am current. అయిపోతే చెప్తుంటే आवाज इसको आवाज हाँ बोल अबे चल
Hello. Hello. Am I audible? Am I audible? Okay.
Yes, yes,
Yeah.
sir.
Thank you. Thank you.
Yes.
So welcome you all to the second part of this workshop. So in this session, we will be going to explore data distribution. So calculating basic statistics as well as how to identify the outliers. Okay, so first and basic step for identifying the outlier is box plot. So we have seen how to do the box plot.
Sir,
Okay.
excuse me.
Yes.
Sir, sorry to interrupt. Sir, can we do that again? Scatter plot for gender.
Yeah. I'll do that. Scatter plot or box plot?
Scatter plot for gender, based on gender.
Yeah. Okay, will do. No issues.
Okay.
So I have to go to Ana graph. Okay. Chart builder. Okay. I have to do the reset. Graph chart builder. So you have to click the reset. Okay. So whichever chart you want, you can select. Okay. So since scatter plot is requested, so I'm just selecting the scatter plot. Okay. So first I want to see. Okay. So what is the average salary? Okay. So generally the scatter plot will be should consist of continuous variable. Okay. So I'm going to use beginning salary and as well as current salary. Okay. So based on the request, so if we want to see it separately for male as well as female, so I'm just selecting the gender in the set color. Okay. I'm just dragging. Okay. So if you want, you can check the statistics also. Okay. So here you can able to see. So separately we have presented the scatter plot. Okay, separately for male as well as female. So if you want to check whether the distribution is normally distributed, so as I said that the general assumption for most of the analysis will be two. One is the data should be normally distributed. Second one is the data should not have any outliers. Okay, so for checking the normal distribution, okay, so there are different methods are there. We will be seeing those things. Okay, so before that, you want to know that whether it is linearly distributed or not. Okay, for that you have to do the double click. Okay, so you have to click the elements. Then since we have two groups, so if it is only one group, you have to use the first option, fit line at total. But if you are having two groups or subgroups, so you have to click the fit line at subtotal. Okay, so then you have to close. Okay, so you will be getting the scatter plot for two different categories. Okay, female as well as male. Okay, how the data has distributed. Okay, the two continuous variable. One is beginning salary as well as current salary. Okay. Second thing is we have seen the important graph is box plot. Okay, for identifying the outlier. Okay, for that what you have to do, go select chart builder. Okay, so you have to click the reset. In this, you have to select the box plot. Okay, you have to select the box plot. Okay, so here I want to check whether the salary data. Okay, so here the x-axis will be the categorical. Okay, so categorical is nothing but employment category. Okay, so the y-axis generally it will be the continuous variable, that is current salary. I'm just dragging here. Okay, so then I'm clicking OK. You will be getting the box plot. Okay, so when you are having some values, okay, above the whiskers, okay, so then the data consists of outliers. Okay, so that is the interpretation. Okay, so here in the presentation, okay, PPT, so here you can able to see that lower whisker. Okay, so lower whisker formula is nothing but Q1 minus 1.5 into so interquartile. Okay, so similarly higher whisker, so lower and higher whisker is nothing but so this will be the lower whisker and this will be the higher whisker, and this is the median. Dark line will be the median, and this will be the Q1, and this top box of the blue box is said to be the Q3. Okay, so Q3 minus Q1, so you will get the median value. Okay, so this is how you have to select. You have to check whether your data has some outliers or not. Okay, so now we are moving to the basic statistics. Okay, so first statistics is nothing but yes, ma'am.
Sir, can we use QQ plot for checking the outliners?
Yeah, we can do, ma'am. So we will be seeing those things in further slides. So there are two different methods are there. Graphical method. Okay, another one is numerical method. So generally I suggest so if you are in advanced stage, so you have to use the graphical method. Okay, so if you are a beginner, better you can use the numerical method. So we will see those things later. Okay, so before
Yes,
that, we will be seeing some basic statistics, how to do frequency table, descriptive statistics table, and all other things we will be seeing. After that, we will also see the how to check the outliers, normality distribution, and all other things using different method, graphical method and values method. Okay, so first we are going to see the frequency. Frequency will be used when your data is a categorical. Okay, but even we can able to use it for continuous, but generally it will be used for categorical variable or discrete variable. Okay, not for continuous variable. So nowadays we will be using continuous also, but generally it will be used for discrete data only. So for that I am going to use the employment data. Okay, so this is the employee. Yeah, it is the employees data. Okay, so as I said that mainly it will be used for categorical or discrete variable. Okay, so the job category is a discrete. That means that three different categories are there. One is clerical, custodial, final one is manager. So I'm going to check the frequency of the values of job category. Okay, so for that I have to go to the analysis. Okay, so within that analysis you have to check the descriptive statistics. So here you first we will be checking the frequency. Next we will be seeing descriptives. Then we will be seeing explore. So for what purpose we will be using the explore. So for what condition we have to use cross tape and all other thing we will be seeing. So as I said that for categorical variable, generally we will be using the frequencies. I'm just selecting the frequency. So here my variable is I am selecting the job category. Okay, so employment category. I'm selecting. Then okay, it will show the frequency table. Okay, so here you can see that. So categorical employees are 363. So 27 custodial and 84 managed. Okay, so you can able to see the cumulative percentage also. Okay, so this is what about the frequency distribution. So for discrete values you will be using the frequency, but if you are having a continuous variable, okay, so then generally we will be using the descriptive procedure. So for that also I will be using the same data set, that is employee data. Okay, so I'm going to select. Okay, so under descriptive statistics we have seen frequency. Okay, generally frequency will be used for discrete. So even it is used for continuous also. Okay, but mainly it will be used for discrete values. So if it is a continuous, we will be using the descriptives. Okay, so you have to select the descriptives. So my variable of interest is salary. Okay, so I am just selecting the current salary. Okay, here you will be having one option called save standardized values as variable. Okay, so it's a z value of that variable. Okay, so it's a standardization. So you may know the what is meant by standardization and normalization of a variable. Okay, so if you want, you can able to save the standardized value as a variable. Okay, so then if you click OK, so then you will be getting the minimum, maximum, mean, standard deviation. So even if you want, you can able to have other indicators also. Okay, so for example, analysis, descriptive statistics. Okay, if you go to option, you can able to select different. Okay, so if you want variance, range, okay, skewness, kurtosis, whatever you want, you can select. Okay, and if you click OK, you will be getting the answer. Also in the main data table, okay, so a new variable will be created. Okay, so here you can see that z salary, that is the standardized value of that salary variable. Okay, so actual variable, so standardization procedure will be that. So if you want the standardized variable, okay, so you can use this method also. So far we have seen frequency. Okay, then we have seen the descriptives also. So now we are going to use the explore procedure. So this explore procedure, okay, generally it will generate a list of, that means that main statistics, you want to create some main statistics. Okay, for our variable. Okay, so then we have to use the explore procedure. So even in the case of explore procedure, it will be used for seeing the histogram also. Okay, so whether the data is normally distributed or not, that can be identified from the explore procedure. So for doing the explore procedure, generally your dependent variable should be a continuous variable and the independent variable should be a categorical variable. Okay, so generally in SPSS they will call factor as a independent variable. So independent variables generally it will be called as a factors. Okay, so generally this explore procedure will be used to identify whether your data is distributed normally or not using the histogram. So I said that generally there are two different procedures are there. So to find the data is distributed normally or not, one is graphical method, another one is numerical method. So we will be seeing those things in upcoming slides. Okay. So I'm going to use the same employee data. Okay. So here my intention is to compute main statistics. So if you want to construct main statistics, okay, for your variable, okay, generally you have to use the explore data, explore option. Also, it will be used for finding the distribution of the data. Okay, so as I said that the dependent variable should be a continuous and the independent variable should be a discrete. Okay, so what I'm going to do, I'm just going to do the analysis. Okay, so within that descriptive statistics, so already we have seen what is meant by frequency, when we have to use the frequency. Descriptive statistics also, when we have having the continuous variable, then we have to use the descriptive statistics. So now to compute the main statistics, we have to use the explore option. Okay, so for that, as I said that I have to construct main statistics for the current salary job category. Okay, so for that I am using the dependent variable. Okay, on the other hand, independent variable generally it's a categorical variable. I am just selecting the gender. Okay, so in the statistics, okay, so whatever you want, you can select. Okay, so if you want outliers also, you can select. Then this is the main thing, plots. Okay, so as I said that you can able to get the box plot. Okay, so box plot generally it will be used to identify the outliers. Okay, so even normality plots will be used to test the data whether distributed it in normally or not. Okay, so once you're done, you have to click the continue. Okay, so here also if you want, you can select the histogram. Okay, click OK. So here we will be getting the results. So this is the main statistics. As I said that explore will be used for constructing the main statistics of a particular variable. So my variable is current salary, as well as I have used my independent variable as a female. So how many number of female? Okay, how many number of male? Okay, so also you can able to see what is the mean, variance, standard deviation, minimum, maximum range. Okay, interquartile range, skewness, kurtosis. Okay, all the things will be displayed. Then extreme values will also be displayed. As I said that generally this explore procedure will be used to test the normality as well as the outliers. So as I said that when you are doing some analysis, you have to check these two assumptions, whether your data is distributed normally. Another one is whether your data should not have any outliers. Then only you can able to do the other statistical test. Okay, so how to find the normal test of normality? So as I said that there are two different procedures. One is numerical, another one is graphical. Okay, so graphical in the sense histogram. Okay, generally we know that if the distribution will be a bell-shaped curve, then it is distributed normally. Okay, otherwise it is not distributed normally. So for that you have to check the histogram. Okay, so it may be in bell shape. Also there are some procedure. So that's why, so if you are a beginner, okay, so better you can stick on the numerical values. Okay, there are some tests are there. So here you can see that Shapiro-Wilk test. Okay, so based on the significance level, easily you can able to conclude your result instead of depending on histogram. So some maybe seems to be in the inverted bell-shaped curve, but some may not be in bell-shaped curve. So based on the graph, if you are interpreting means, then you have to be an expert. Otherwise, better you stick on the numerical values like Shapiro-Wilk test. Okay. So I'll show how to see whether it is distributed in bell-shaped or not. Okay. So then one participant has asked the question. So normal QQ plot. So based on this also we can able to find so whether it is distributed normally or not. Okay. So when it is beyond the line. Okay. So when the distribution is beyond the line, then we can able to say that it is not normally distributed. So also you can able to see the box plot when you are having some outliers. Okay. So earlier we have seen about the normality test. So now we are seeing about the outliers. So when there is outliers, then you will have some values above the whisker. Okay. So based on this, you can able to conclude whether you are having whether your data is distributed normally and also it does not have any outliers. Okay. So this is what about the importance of explore option.
Excuse me, sir.
Yes.
Excuse me, sir.
Yes.
Can you explain that the numerical normality test, how to interpret this or how to understand that is not a normal?
Actually, it is in the slider. So before that, if you want, so you have to check the Shapiro-Wilk test.
Yes, sir.
Yeah. So I have provided null hypothesis as well as alternate hypothesis. If it is significant, you have to check whether you have to reject the null hypothesis or you have to accept the null hypothesis. According to the significant value as well as null and alternate hypothesis, I have provided in the slide. Okay. So accordingly, you have to check whether it is normally distributed or not. Actually, it is there. Okay. So while seeing the outlier, then we will see those null hypothesis as well as alternate hypothesis. Okay.
Sir, you told that there is two tests for normality and there is some significant range for that test. May I know the
yes, ma'am.
value?
So I'll show because now we are going to see only the basic statistics. Okay. So now we are not getting into the outlier procedure. Okay. So we'll see. It is in the slide only. Okay. I'll show.
Okay, sir.
Yeah. Okay. So next one is crosstab. So crosstab generally it will be used to see the relationship between the two categorical variable. Okay. So for that we will be using the crosstab. Even for chi-square analysis also it will be used. Okay. I'll show. So because still t-test is there, ANOVA is there, chi-square test is there. Okay. Before that we just see the basic descriptive statistics in SPSS. Okay. So so far we have seen under descriptive statistics, we have seen frequency. So descriptives, explore procedure. Now we are going to see the crosstabs. So this crosstabs will be used to see the relationship between the two categorical variable. Okay. So for that, I'm going to use the same employee data. So for doing crosstab, so as I shown earlier, so analysis, descriptive statistics. So then you have to check the crosstabs. Okay. So here you have to select the crosstabs. So also, as I said that it is used to show the relationship between the categorical variable. It is not for continuous variable. So due to that, I am selecting the two categorical variable. One is gender, another one is job category. So for that, I have to select the row. Okay. So the row will be the gender. Another one is job category. Okay. So both are categorical. Okay. So I have to select the thing. So even if you want to check, so as I said that even you can able to use observed on expected frequency. So in the case of running chi-square test and all other thing, okay, we are not going into that. Okay. So once you're done, you have to click OK. So you will be getting the cross table. That means the two categorical, female and male, as well as different type of employment category. So you will be getting the values. Okay. Okay. What is the count? Okay. So then we will be moving to the test for normality. Okay. Many of you have asked the question how to check the normality test. Okay. So as I said that whatever analysis you are doing, okay, so before that you have to check the normality assumption, okay, as well as you have to check whether the outliers are available or outliers are present or not, okay. So most of the statistical procedure requires us to verify at least two assumptions. So as I said, that one is normality assumption, second one is outlier, whether the outliers are present or not, okay. So as I said that there are two methods are available, okay, to check the normality assumption. So first one is numerical method, another one is graphical method, okay. So first we will be going to see the numerical method. So numerical method based on the value of skewness and kurtosis, okay. So we can able to interpret whether the data is distributed normally or not, okay. So for that we will be going to use the first numerical method, okay. So for that we are going to use the insured data. I'm just closing the data. And I am opening the insured data. So in the insurance database, so they have given different information about the insurer. Okay, so case weight means that particular subject's weight, okay, of the insurer. So here I want to check whether the variable, okay, this case weight is normally distributed or not. Okay, so as I said that we can able to use two method. One is graphical method, another one is numerical method. Okay, so first we are going to use the numerical method, okay, that is skewness and kurtosis. So for that I am going to use the variable that is case weight. So for that I am going to click analyze, okay, descriptive statistics, okay, then descriptive statistics. Here you have to click the case weight, okay, weight of case. Okay, so then you have to go to the option. So in this option you have to click skewness and kurtosis value, okay. So then you have to click OK. So according to this value, okay, this is the skewness and kurtosis value, okay. So this is based on this skewness and statistics value you can able to find. Otherwise you can able to see so go to analysis, descriptive statistics. So here you have to click save standardized, okay, standardized value as a variable, okay. So you have to click OK. So new variable will be generated. Okay, so here you can able to see new variable has generated, that is SRMCAS, that case weight. Okay, so here how to find whether my data is distributed normally or not. Okay, so here this is the thumb rule. Okay, so if this standardized value, okay, lies between the range, that is minus 2.58 to plus 2.58. Okay, then you can able to say that my data, okay, in my case, that is case weight, is normally distributed. Okay, so how to check, okay, whether it is normally distributed? So I have generated the Z case weight. Okay, so then I have to check whether it is distributed between this minus 2 to 2 point something to plus 2 point. Okay, for that what I have to do, I have to right click. Okay, then sort ascending or descending, whichever you want, you select. Okay, so here this is the maximum value. So the maximum value is 2.40. Then what is the minimum value? So the minimum value is 1.93. Okay, so accordingly you have to check that whether it is lies between the range, because this data, okay, lies between this range, because the maximum value is minimum value is only minus 0.93. Okay, so here the negative value is minus 2.58. It is within the range. Also the maximum value is 2.40. Here the maximum value is 2.58. Okay, so that means that you can able to conclude that my data is distributed normally. Okay, so this is with regard to the first way of Okay, so identifying the normality of the variable. Okay, so as I said, that first one is skewness and kurtosis indicators. Second one is Shapiro-Wilk test. Okay, so as you have asked that, so what is the null hypothesis and alternate hypothesis? Okay, so for that you have to check. So again, I am using the same variable case weight. Okay, so whether the data is distributed normally or not. Okay, so for that, what I am going to do is I'm going to do analysis. So descriptive statistics. So within the descriptive statistics, you have to click the explore. Okay, so then you have to select the variable. Okay, so my variable is case weight. I'm just selecting the case weight. Okay, so in the plots, you have to check this one. Okay, so you have to check the normality plots with the test. Okay, so then you have to click continue and OK. So here you can able to see the QQ plot. Okay, also Shapiro-Wilk test. Okay, so even in the case of graphical method also you can able to use this one. Okay, or for numerical method also you can use this. So if it is a numerical, this Shapiro-Wilk test. Okay, so you can able to see the significance. So I think in the post-lunch section you will be having a special session on how to say it is a significant variable or not. So here actually it is not significant. Okay, so it is less than 5%. It is more than 5%. Okay, so it is 33%. Okay, so that means a 33% error. Okay, so in that case it is not significant. Okay, so if it is not significant, okay, so you have to accept the null hypothesis. So what is the null hypothesis? So the null hypothesis is the variable is normally distributed. That means that so your data is distributed normally. So because already the skewness and kurtosis test, it proves that the data is normally distributed. On the other hand, so this Shapiro-Wilk test also says the same. So even you can able to check the graphical method. So I'll come to that also. So this is the graphical method. So graphical method, generally we will be using histogram as well as QQ plot. Okay, so I'll come to that also. So how to test the normality using the graphical method. One is histogram as well as QQ plot. Okay, so for that, so first we will be seeing the QQ plot also because already we did this analysis here. Okay, so this is the QQ plot. So when this distribution is more or less on the line, then it is said to be the data is normally distributed. But if it is far away from this line, then it is said to be the not normally distributed. So due to that, I am suggesting, so if you are a beginner, then you can use this values instead of graph. So you can use the values for interpreting your results. Okay, if you are in advanced level, then you can able to use the graphs for interpreting the outliers as well as the normality distribution. Okay, so now we are moving to the histogram. Okay, so using histogram, how to check the normality. Okay, normality of the distribution. So for that, I am going to use the same data. So analysis, so descriptive statistics. In plots, okay, I am just clicking the histogram. Okay, so if you want, you can click the normality plots also. Okay, then okay. Here you can able to see the histogram. Okay, so how to say when the data is normally distributed. So when this distribution should be a bell-shaped curve, then only you can able to say my data is distributed normally. Already we have proved the data is normally distributed based on Shapiro-Wilk test and other test. Okay, so now we are going to use the graphical method. One of the method is histogram. So how to put the bell-shaped curve here? For that, you have to click the double click. Okay, so you have to go to the element. Okay, so the distribution curve. Okay, So this is the normal distribution curve test or non-parametric test. So that is the interpretation. Okay. So on the other hand, how to manage the outliers? So there are three kinds of outliers. Okay. So depends on the situation. So first one is data entry errors. Okay. That means that if I went for a field, okay. So due to my negligence, okay. So due to my tiredness, I have entered wrongly. Okay. So in that case, you have to find that invigilator, okay, or the field investigator, okay, so that you can able to rectify your data. Okay. So outliers is nothing but, so it is beyond the level. Okay. That means that generally it will be present upper the whisker level. Okay. So in that case, it can be fixed when there is a data entry error. Okay. For example, after collection of data, so you have to convert it into hard copy to soft copy. Okay. That means that you have to type the data. So in that case, only one person is feeling tired, or he's not that much careful. Okay. So you can find the respondent and you can able to rectify those issues. So second outlier will happen because of measurement or data collection error. Okay. So either it may be human mistake or maybe the malfunction of the machine. Okay. So because nowadays we will be using so many softwares. Okay. So either it may be free software or else paid software like Kobo tool we are using, Survey CTO we are using for collection of data. Okay. So if there is any malfunction, okay. So for example, even in our case, we have collected for a ministry project. Okay. So when we are entering crop name as a ragi, so it is taking French bean. Automatically it is taking French bean. So we have identified and we have informed the same to the ministry. So due to that, they can easily rectify that measurement error also. Okay. Somewhat they can able to rectify those things. But the genuine outlier, okay. So it is said to be the non-typical error. Okay. So that means that because of typing, okay. So if the error is happening means then we can able to rectify. So, but some cases, so genuinely you will have some outlier. That means that, so you will get what is your income means they may say that very higher amount. Okay. So even in the case of input usage also, they may say higher yield, they may say higher or very lower. Okay. So those are said to be the outliers. Okay. So those are all genuine outliers. So you have to find the reason for that outliers. Okay. So on the other hand, so if I am having some outliers, then what I have to do? Okay. So generally what we will do, so we will be removing the outliers. Okay. Generally that is not the procedure. Okay. So if you are removing the outliers, so you will be losing the information. Okay. So if it is a genuine error, genuine outlier. Okay. So if it is a genuine outlier and you are removing the outlier means, so you will be losing the informations. So for that, what you have to do, you have to replace it with the mean. Okay. One way. Another way is you have to keep the extreme values in the data series. Okay. So with some conditions. Okay. So there are some possible routes. Okay. So first thing is, so as I said that you have to run the both parametric as well as non-parametric. Okay. Generally we will call it as a sensitive outlier. Okay. So if it is sensitive to the outlier, then you will have different results for parametric test as well as non-parametric test. Okay. So second thing is replace the outlier with the values closer to the normal. For example, so normal is 3. Okay. So for example, normal seed usage is 3 kg per hectare. Okay. But I am having some outlier. It is showing that there are some outliers are present. Okay. So in that case, you should not remove all the outliers. Okay. Initially, you have to remove maximum outlier. Okay. That means that first you have to remove this first one, because it is very far from the. Okay. Then you have to run the analysis. Then you have to check the result. Okay. Then you have to interpret. Okay. So initially, whatever the outliers are available, you should not remove entire outliers at one stage. Okay. So you have to do it step by step. Then only you can able to get a solution for this outlier issues. Another one is you have to run the parametric test regardless. Okay. So as I said that since parametric test, if you are run whether it is violated the assumption. Okay. So now outlier assumption as well as distribution assumption. So even you can able to use the parametric test because it does not follow any distribution. Okay. So that's why in the case, if your data is violating the assumption, okay, so instead of using the Pearson correlation, you can able to use the Spearman rank correlation. Okay. So finally, sensitive analysis, as I said that you have to use both parametric as well as non-parametric test. So accordingly, you have to interpret the results. Okay. So if both the parametric and non-parametric having the same results, then it is not sensitive to the outlier as well as the distribution. Okay, normality distribution. So then you can able to use either parametric or non-parametric, but it is sensitively affecting the results means then you have to look into your data and you have to revise the data. So on the other hand, data transformation is also one of the solution for the skewed data. That means that the data is not normally distributed. So if it is normally distributed, generally it will be in the bell-shaped curve, but it may be positively skewed or negatively skewed. Okay, then you have to do the data transformation. Okay, so after running the sensitivity analysis, you are getting different results for parametric as well as non-parametric. Then what you have to do? So you have to do the transformation, data transformation. So before that, you have to know whether it is positively skewed or negatively skewed. Okay, so generally you have to know that what is meant by positively skewed or negatively skewed. Okay, so if it is normally distributed, as I said that, so it will be in bell-shaped curve. Okay, so but if it is positively skewed means, okay, so the distribution will like this side. Okay, okay, so this is in the left hand side. Okay, then that is positively skewed. Okay, so if the data is in the skewed in the right hand side, okay, then it is negative skewed. Okay, so according to the skewness, so you have to do the transformation also. So before that, you have to know that some drawbacks of the data transformation. Okay, so first one is it is not always successful. So for example, my data is not normally distributed. Okay, so then I am doing some transformation. Okay, so there is no surety that so your data will converted into normality. Okay, so that is one of the drawback. Okay, another one is it is difficult to interpret the result. Okay, so when the data is converted into square root terms or some other transformation, it is difficult to interpret the data. So final one is, so for example, if I am having two different types of groups, okay, one is male and female, okay, income. So the income data is not distributed normally. If I have income of female is not distributed normally, but income of male is distributed normally. So in that case, it is generally we have to do the transformation as a whole. Okay, both the gender. Okay, in that case, it is a big drawback for transformation. Okay, these are the main drawbacks for the data transformations. I'll show how to do the transformations also. Okay, so as I said that, so before that you have to check whether it is positively skewed or negatively skewed. Okay, moderately or strongly. Okay, so I'll show, okay, how to do the data transformation. So using the employees data. It is insure data. I'll be opening the employees data. Here I am going to take the variable. Okay, the variable of my interest is salary. Okay, so I want to transform this salary into a different variable. Okay, so I don't know whether it is distributed normally or not. Okay, since we don't have time for checking the normality and other thing. Okay, so I'm just going to transform the data. Okay, for that what I have to do, so you have to click the transform. So you have to click the transform. So within that you have to compute a new variable. Okay, compute a variable. Okay, so in this case, okay, so what I have to do, my interest is, so my target variable is, so I am just typing it as salary 2. Okay, so that is my new transformed variable. Okay, so my I'm going to transform this current salary, okay, this variable. So here you have to give the numeric expressions, okay. So according to the results of skewness and kurtosis, okay. So I'll show it here, okay. So here you can see these are the types of transformation. So as I said that if it is moderately positively skewed, so I have shown here, okay. So whether how a normally distributed curve will be there. So here you can see, so this is the normally distributed curve. So if this is the positively skewed curve and this is the negatively skewed curve, okay. So according to that, you have to do the transformation. So these are all the thumb rule for doing the transformation. So based on the results, so they found that, so when your data is moderately positively skewed, so when you are taking the transformation as a square root, so then the data will be distributed normally. So these are all some of the thumb rule. So according to the distribution, you can able to do the transformation. So as of now, so I am assuming that it is moderately positively skewed. So in that case, I have to take square root of x. Okay. So my x variable is nothing but, okay. So my x variable is the salary. So in that case, I have to type sqrt. Okay. So here I have to select the current salary. Okay. So this is my variable of interest. Okay. So then the new salary will be generated, salary 2. So here you can able to see this is the new variable will be selected as a salary 2. Similarly, you can able to do the same procedure here also. So here I have given quotes. Okay. So as I said that 90% will be in menu driven only in the case of SPSS. Okay. So only 10% like data transformation and all other things, you have to use the code. It is very simple. So if you do the Google, okay, so you will get the codes also. Okay. So here, as I said that here you can able to see that. So if it is a square root and if it is moderately positively skewed, so you have to use the square root. Okay. So if it is strongly positively skewed, so you have to use this command. Okay. So according to that, you can able to do the transformation. Okay. So now we are moving into the basic analysis. Okay. So before doing any analysis, as I said that you have to check the assumptions. So main assumptions. Okay. Not all the assumptions, at least main 2 assumptions. One is normal, whether your data is distributed normally. Another one is your data does not has any outliers. Okay. So then only you have to get it into the t-test or other parametric test. So otherwise you have to go to the non-parametric test. Okay. So now we are moving into the one sample t-test. Okay. So generally it is used to compare the means. Okay. So sample mean with the population mean. Okay. So here I have given the null hypothesis. I think in the post-lunch section, you will be seeing what is meant by probability. So how to accept the null hypothesis, how to reject the null hypothesis and all other things. Okay. So due to paucity of time, I am just showing that. So what is meant by null hypothesis and alternate hypothesis. Okay. So generally it will be used for testing the mean. Okay. So you can able to compare the population sample mean and population mean. So sample mean in the sense you are going for a data survey and you are collecting the data, so you can able to compare the results. Okay. So this is what about one sample t-test. So I think it will be discussed very detailedly in the post-lunch session. Shall we have question and answer session, or else we will go to other test also? So yeah, okay. So I'll show how to do this one sample t-test. Okay, with an example. Okay, since we have 20 minutes time. Okay, so I don't want to get into the assumptions and all other thing. So as I said that mainly you have to check main 2 assumptions. One is whether the data is distributed normally and whether it does not has any outliers. Okay. So here, as I said that one sample t-test is nothing but whatever data you have collected. Okay. So generally it is nothing but mean comparison. Okay. T-test is nothing but mean comparison. You are going to compare your sample mean with the population mean. So population mean in the sense, for example, if I am going for a data in Tamil Nadu or some states. Okay. I'm just collecting some observations. Okay, so whether that salary is more or less equal to the entire state salary. That means that samples mean is equal to the population mean. Okay, so that is the usage of one sample t-test. Okay, so here we will be so here they have given the insurance database. Okay, so I am going to use the insure database. I'm just closing this. No, save changes. No. Okay, so I am just opening the insure database. Okay, so here I want to check that. Okay, so I want to check whether the average weight. Okay, so already we have seen the case weight variable. That means that weight of the case has satisfied both assumption. So it is normally distributed as well as it does not has any outliers. Okay, so due to that I can able to use the t-test. Since it's a parametric test, I'll be using the t-test. Okay, so for case weight variable. Okay, so here I want to check that whether the average weight. Okay, since t-test is used for checking the mean. Okay, since it's a sample data, it's not a population data. So this sample weight is equal to the population weight. So based on the secondary source, okay, so I came to know that, okay, the average weight of the population is 81.19 kg. Okay, so this is the population weight. So I want to check that whether the mean of the sample mean is equal to the population mean. That means that whether my weight is equal to average weight is equal to the overall weight of the population. Okay, so for that I am going to use this one. Okay, so for that I am going to do the analysis. Okay, so I have to click the analysis. So here you have to go to the analysis mean. Wait a minute. Compare means. So here you can able to see that one sample t-test. Okay, so here you have to check the weight case. Okay, so weight case in kgs. Okay, so here you have to give the test value. Okay, so as per this one, so the mean population is 81 point. So here the population mean is 81.19 kg. Okay, so for that I have to give 81.19. Okay, so then I have to click OK. In the afternoon, so based on the one sample t-test result, okay, significance level. Okay, so here I think in the post-lunch session you will be discussing about how to identify whether it is significant or not. Okay, so as of now I'm just showing what is the mean. Okay, so here mean is 72. Okay, the mean is 72. Okay, the sample mean is 72, but we are testing with the population mean is 81. That means that it is there is a drastic significance between the population mean and sample mean. Okay, so that is the interpretation. Based on the significance score you can able to interpret. Okay, so whether you have to accept the null hypothesis or reject the null hypothesis. Okay, so by seeing the mean value itself you can able to say, okay, whether it is whether the average weight of the both sample as well as population are same or not equal. Okay, so that is with regard to one sample t-test. Okay, so even you can able to use the binomial test also. So binomial test is nothing but when your data has dichotomous. Okay, that means that 2-1. Okay, that means that it's a male female like that. Okay, so it compares an observed distribution with the theoretical one. So earlier we have compared the sample with the population. So in the case of binomial test, it will compare the observed distribution with the theoretical distribution. So I'll just run the analysis because you will be discussing more on the post-lunch session, because it is especially you will be knowing how to say it is significant or not, okay, based on the probability value and all other things. Okay. So main thing is
one
this.
doubt, sir.
Yeah. Yes, ma'am. Hello.
Sir, you said that before ensuring different statistical techniques, we should ensure whether the data are normally distributed and there should be no outliers.
Yes, ma'am.
And whether it is sir, similarly, whether the reliability analysis should be performed after practicing all these statistical techniques, it is also necessary.
Yes, ma'am. So if it is already satisfied, it is not necessary, ma'am. Ma'am, if already it is satisfied, that means that your ma'am, am I audible? So if it is already satisfied, that means that your data is distributed normally, and it does not has any outlier, means then no issues. But if it is there, so if it is there means then what you have to do? So you have to do parametric test as well as non-parametric test. Okay. So for the same data, for example, so my data has violated the assumption. Okay. So it is not normally distributed and it has some outlier. So in that case, what I have to do? So in that case, what I have to do? First, I have to run the non-parametric test. For example, Spearman's rank correlation. So Spearman's rank correlation is a non-parametric test, as well as you have to run the parametric test, that is Pearson rank correlation. So Pearson correlation. Okay, so that is parametric. Another one is non-parametric. So then you have to compare the result. Okay, so if both results, both parametric and non-parametric, are providing same results, then no issues. That means that your outlier and distribution is not significantly affecting the results. That means that it is not sensitive to the results. So in that case, you can either use non-parametric or parametric test. But if it is significantly affecting the results, then you have to do the changes like transformation I have mentioned, no ma'am. So there are different procedures are there. So you have to replace with the mean and all other things you have to do. Okay.
Okay, sir. Okay, sir.
Yeah. So now we are going to the chi-square for goodness fit. Okay. So generally it will generally the chi-square will be considered as both parametric as well as non-parametric, but generally it will be considered as a non-parametric test. Mainly it is considered as a non-parametric, but it will be comes under both parametric as well as non-parametric test. So here generally it will be used for not nominal. Okay, so with at least 3 categories. Okay, so we will be taking one example. Okay, so generally it is a it's not a nominal and it has 3 categories. So for that, first you have to check the assumptions. Okay, so what are the assumptions are there? So you have to check the assumptions. So when the assumptions are satisfied, then only you have to use, then only you can able to use the chi-square statistics. Okay, so for that I am going to use the serial database. Okay, so I'm just closing this data.
Hello, sir. You're not audible. Hello, sir.
Hello. Am I audible?
Yes, now.
Yeah.
Yes,
Okay.
sir.
Yeah. Thank you. So here you have to check that. So this is the 3 different preference of breakfast. Okay. So we have to check whether observed distribution is equal to the theoretical distribution. So one of the advantage in SPSS is it automatically calculates the theoretical distribution. So first we are going to see how to check the observed distribution. So observed distribution is nothing but frequency. So for that I am going to do the analysis. So within that descriptive statistics, okay, frequency, okay. So here preferred breakfast, be fast will be the variable, okay. So then I am clicking OK. So here you can able to see that this is my observed distribution, okay. So I have to check the theoretical distribution. So in the case of SPSS, I said that it automatically calculate the theoretical distribution, okay. So how to do that? So for that I have to click the analysis menu. So here you have to select the non-parametric test. So here you can see there are different types of tests, okay. So but my interest is to do the chi-square, okay. So in that case I have to click the legacy. So in that legacy dialogs, so I have to check the chi-square, okay. So once I have selected the chi-square, I have to select the variable be first, okay. So then I have to select the expected range. Already defaultly it is selected. Get from data. So as I said that advantage in the SPSS is, so it will automatically calculate the theoretical distribution, okay. So then expected value. So I have mentioned all categories, okay. So according to your objective, you have to select, okay. So then I am clicking OK. So then you will get the preference. So generally we have seen that in the case of t-test, so we have compared the population mean with the sample mean, okay. So sample mean of the salary is around in the case of weight is 72 kg, but in the case of population weight is 81 kg. So there is a significant difference. Similar to that, so in the case of breakfast preference, okay, so here you can able to see that 3 different preferences. So for breakfast, cereal, oatmeal and breakfast bar. So by seeing the observation itself, you can able to see that, so there are significant difference. So 339 people, they preferred cereal for their breakfast, 310 for oatmeal and 231, okay. So but statistically you need to prove, so according to the significant value, okay. So based on the significant value, you can able to interpret your results, okay. This is what about chi-square test, okay. So finally I think the time is running. So finally we will be seeing the correlation test. So generally there are 2 types of correlation. One is Pearson correlation, another one is rank correlation, that is Spearman's rank correlation, okay. So according to your data, you have to use that use your analysis, okay. So generally Pearson correlation is a parametric test, okay. It should follow some distribution, okay. So as per the assumption, you should follow normal distribution. Also, it should not be any outlier. Then only you have to use the Pearson correlation. But if it is violating, then you can able to use the Spearman rank correlation. On the other hand, so for qualitative variables like categorical variable, you can able to use the Spearman's rank correlation, okay. So this is the basic difference between the Pearson correlation and the rank correlation, okay. So generally rank correlation will says about the linear relationship between the variable, but regression says about the impact, okay. What is the impact of fertilizer on yield, okay. That can be impact can be captured using the regression, but association or relationship can be captured using the correlation only, okay. So these are all some of the basic thing, like whether it is strengthly correlated or else weak correlation and all of things. So I just share the procedure. So here these are all the assumptions, okay. So it should satisfy all the assumptions, then only you have to use the parametric test, okay. So we will be using the insured data, So we will be using the insure data. I am just closing this one. And we will be opening the insure data. So my variable of interest is between case weight and height. Okay. So these two are a continuous variable. Okay. It's not a categorical variable. If it is a categorical variable, generally you have to use the Spearman rank correlation. Okay. On the other hand, if it is not following the distribution or assumption also, you can able to use the rank correlation. Okay. Otherwise, if it is a continuous, then you have to use this Pearson correlation. So how to run the Pearson correlation? So I'm going to relate to height as well as weight. Okay. So so I have given the procedure for checking the assumptions. Okay. So but my intention is to run the Pearson correlation. How to do that? So you have to go to analysis. Okay. So here you can able to do the correlate. So within the correlate, you have to select the bivariate. So within the bivariate, as I said that we have to select the variable. Okay. Case height and weight. Okay. So case height. So case height of case. So you have to click control and case weight. Okay. Then you have to select here. Okay. So here you can able to see that which correlation. Okay. So if it is a Pearson correlation, you have to click here. Otherwise, Spearman's rank correlation, you have to click here. I'm just selecting the Pearson correlation and I am clicking the OK. Here you will be getting the significant results of the correlations. Okay. So here the correlation matrix will come. On the other hand, even if you can use Excel sheet also for running the correlation, but you won't get the significant value. The advantage in SPSS is, so you will be getting the significant value for correlation. Okay. According to that, you can able to interpret your result. Okay. So also you can able to use the Spearman rank correlation. One thing is, so here you can so go to analysis. So correlate, bivariate. So instead of Pearson correlation, you have to click the Spearman correlation. Okay, then okay. So you will be getting the non-parametric results of correlation. Okay. Hope it is clear. Already time is 1 o'clock. So shall we take? Shall we wind up, or else we will take? So you just share your questions to the organizers. I think they will collect the questionnaire. We will reply to that.
Thank you, sir.
Yeah, thank you. Yeah, thank you all.
And next is
So next session will start at 2 o'clock sharply. Please join our post-lunch session. Thank you.
1 to 2 break.
1 to 2 break.